Yeah, hi. So in this video, we are going to discuss about streams flat map. Okay. So many times one element in a stream can generate multiple values. For example, a sentence can have many words, a person can have many phone numbers, a product can have many tags, a folder can have many files. So the idea of flat map is convert each element into many things and join them or flatten them into a single stream. So let's say we have a list of sentences here like hello world, Java Streams API and flatmap SS map. Okay, so what we do is we convert them, we split them into words, and so that all the sentences which we have are converted into words in this way. So idea here is split the sentence into words and flatten them so that we get a list of all the words. That's where flatmaps comes into picture. So a flat maps expect a function, okay, that takes an argument, and the argument must be something that returns a stream. Okay, so it receives an argument. For example, for example, it receives a sentence, and sentence can be split into words, which is nothing but and they can be converted into an array of streams, and then we can flatten them out. Okay, so it returns a stream of items. So let's take an example using a code snippet here. So we have a sentence here. For example, hello world, Java Stream API, and flatmap SS map. So we have a list of sentences here. So what we do here is, and this is what we expect as an output. So first, we create a stream of sentences. Okay, just like hello world using lines.stream. We create a stream of sentences, and for each of those lines, we split them. For example, we let's say here we having hello world, so the hello world is converted into an array, like hello world. Okay, and similarly, we split them using space, so those are sentence are converted into words here. Okay, so for each line we get an array of words. The next step, what we do is we convert each array into a stream. So the hello world array is converted into stream of hello and world. And then what we do here is we apply flat map. So a flat map each takes a stream of words here and flattens them out into a single continuous stream. So so instead of this streams which we got earlier, right? Stream of hello world, stream of Java. So we get a single stream here of all the sentences, and then we return them as a list. So we get a stream of. So what flatmap essentially has done here is it has flattened all the streams here into words in this manner. So we get an output in such a manner. So this is a flat list of all the words for all the given sentences. Okay. So this is again one more use case wherein here instead of we are having a list of sentences here. So what we do here is we take a list of all the sentences and convert them into an array of sentences this way. So what essentially here happening here is we have a flat map here. We taken the list, and one of the important quality, it should return a stream. So here we convert that list into a stream and return it. So just here we want the list of all the sentences flattened. So if you see here we have a list, okay, and the output here is a list of strings. So we have flattened all the sentences. Okay, we can just apply a single flat map here. So if we want to just convert this sentence into a list of words here, what we can do here is we can initially we did just a single flat map. We can add one more flat map here. Just like we did in the previous example, we split each of the sentences and convert them into an array of words, and then convert them into array of streams here, and then we flatten them out. So it is essentially the same as we saw in the previous example. So this is how we get the output. So we are just converted each sentences list of all sentences into the words. So this is a flat list of all the words for all the given sentence by applying flat map twice. And carrying on further, so we can also count all the words here, like we have just flattened out here all the sentences basically here, and let's say we want to find the count of all the words here. So what we can do is we apply a count here, and it will return a count of all the words in a given sentences. On similar lines, if you want to find the distinct count, because here this is an all repetitive, just like if you want to get a distinct count of all the words, after flattening them out, we use distinct, and then we do the counting. So we get a 6 as a distinct count of all the words for all the given sentences. On similar lines, let's say one of the other use cases is, if you want, let's say you want to remove an empty list. So we have an empty list here as shown in the above example. So let's say we want to flatten them out, or you want to remove the empty. So we can just, what we can do, we can just flatten them out. Automatically it will remove the empty list here. The other example is, flattening the optional values here. Okay, let's say we have an option value here and we just want the 10 and 20 as a value. So, and also we have additional empty here. On similar lines, we can use a flat map. We can create a stream of that optional and then we convert it into a list. So we get an output this way. So this is essentially going to flatten out all the optional values. Okay, carrying on with the further example, let's say we have a list of sentences as seen in the previous example. So we did, the steps are very similar. We flatten out the sentences, and from the sentences we flatten out all the words here. And what we do here is to find out the frequency of all the words here, we actually use a collectors that group by. So what we do here is whatever words which you are collecting here, right? We're partitioning the group by those words, and then we're calculating how many words are there. So we use something called as a downstream collector here, collectors dot counting, and after grouping we collect them into a map. So here the string would be the word, and the count, and the long here would be the number of count here. For example, here the sentence is 3, third is third word is repeated 1 times. Similarly, this here is repeated 3 times. So on similar manner, if we see, it returns a map, and the key here is the word, and the count here is the frequency of that specific word here. This is also one of the use case which you can use with flatMap. Okay, and let's say initially we are using only primitive values. For, let's say we have a custom object here. Let's say as a user, and let's say each user is having multiple phone numbers. I've just taken a dummy phone numbers here, okay, just to illustrate it. So let's say each user A is having 2 numbers and user 3 is having 3 numbers. Let's say in your project you require the list of all the phone numbers of all the employees, right? So in that case, what we can do here is, as I say, we can get the phone numbers here, get user.get phones, and we can stream it. Okay, we stream all those things, and then we flatten them out. So we'll get a list in similar manners. So let's say we want to get a list of phone numbers or hobbies and all that stuff, we can use this flat map to so that we can get the listing of all the phone numbers of all the employees. So there are few differences between map and flat map. So a map can produce one output for each. Okay, but here the flat maps can produce multiple outputs for each input. And map doesn't flatten any nested structure. We have seen in flat map that it flattens the nested structure. For example, list of list is converted into list, and the mapper only does the transformation and it returns a single value, whereas the mapper here returns a stream of list or an array, which is going to get flattened. So use case here is, it is used only for transforming the object. Here it is used when extracting or expanding the collections inside the LMS. So let us write some code. Okay, so we will take the same examples as we are using in the slide. Okay, here we have a list of sentences, and then what we do here is we apply a flat map on them. So essentially we split those sentences into words, convert them into array of words, and then convert them to array of streams here, and then we flatten them out. So let us see the output here. Yeah, so we can see we have got all the words here for all the given sentences on similar lines. So let us, okay, we have seen this as a sentence. So let us use this example which we saw in the slide. Okay, all the words. So here instead of list of sentences, we have list of list. Okay, so similar example, just here we are having a list of sentences like a, okay, and again what we do is on first time we do convert those sentences into a stream of we flatten those sentences into a list, and then we convert each sentences into words here, and then for all the words we just flatten them out. You can see we have split each sentence into words. I mean, essentially, we've taken all the sentences and we have given the words for all those sentences in in a list. Okay. Okay. On similar lines, what we can do here is we can just find out what is the count of that sentence. Okay. Same example. We'll just use a count here. So after flattening them out, we just find out what are the count of all the words. So we have 12. So, okay, this is the number of words in a sentence. So we can apply a distinct here, okay, and just find out the unique number of words in a given sentence. So we have 6. So on similar lines, we have found out distinct. So we can also use this to remove the empty list, okay, which we saw earlier. So this is an empty list. So essentially, it will just remove that specific list. You see, an A, B, and C. It has removed the empty list. Also, we can flatten the optional values. So we'll just take that as a next example here. So we have our optionals here. Okay. And okay, this is an optional here. We'll just flatten out all the optionals. This is an empty here, and this is all the optional values. You see, we have flattened all the optionals. So the last example which we saw is the finding out the frequency of the words. Okay, this is the frequency of the words. Okay, I have to take the sentence also. I've just forgotten it. So yeah. Okay, so this is the list of sentences which you have taken, and after flattening it, we are grouping it based on the partitioning it based on the word here, or grouping it based on the word, and for the each word we are finding what is the frequency here available. Okay, and the last example is okay, list of all the users here. So okay, we'll just take this as an example. Okay, so we have a user class created here which is having a name and a phone number. So a very simple example here, and based on that we have created the list of users. So and then we are flattening out the phone numbers here. There we go. So we get a list of all the phone numbers for a given users. Okay, that's it from my side. I hope this tutorial was very helpful to you. Thank you.